Hey everyone, this is Andy Melbuff, and this video is going to take a look at using timers in Desmos Activity Builder to show graphs dynamically. Now, what we can do is we can activate timers in a couple of different ways. We can have students press a submit on an input question, or we can also use an action button to have them press it. So what is a timer needed for? What do we need a timer for? Well, let me give you an example here. Let's say I have a particular slide where I want the students to enter a linear equation to match a graph. And I've got a line over here. And if the student starts typing in something like 2x plus 1, you'll see it being graphed instantaneously. And that allows students to do a little bit of guessing and checking. Maybe they don't have to think very much about what the slope and the y-intercept are, as long as they can guess and check. And maybe we want the student to commit to thinking about it and not getting any interpretive feedback until after they press the submit button. So we can take care of that using Computation Layer. So I'm going to exit the preview mode here. And you can see here I've got a note, I've got an input right below it. I've already labeled that input or named it as input number 1. And I'm going to take a look at what I have here in the component. In the first line here, I have the line that I want graphed, and I usually make these matching graph situations. I make them a dashed line, and I make it, this is a new feature in Desmos I really like. You can change the opacity of this and make it a little less bold in there, which I kind of like if we're going to try to graph over it. So anyway, that's the one that's showing to the students. But I also want graphed whatever the student inputs. So I also want Desmos to graph y equals f of x. Well, right now, Desmos doesn't know what f of x is, and it prompts you to add a slider. Well, we're going to define what f of x is in the computation layer. So I'm going to show you what that script looks like again, and this was talked about in some earlier videos, so hopefully you viewed some of those. We use the function sync, and we define function here as the simple function, and it takes the student's input, the LaTeX of it, and it assigns it to that function. So this basically says, take what the student inputs and allow it to be graphed in the component. Now, what we want to do is add a timer to tie that to the submit button. Well, what is a timer? So let's go back into this component here, and let me show you what a timer might look at done right here. We're going to add a restriction, and we have to use curly brackets for that. Some people call it a domain restriction, but I'm going to let x be less than capital T. I use capital T for all of my timers. And so Desmos recognizes T is not something I know right now. What is it? Do you want to add a slider? Well, for purposes of right now, just to show you this manual slider, I'm going to go ahead and add it. But you don't see anything graphed because Desmos doesn't know what f of x is right now. The student hasn't input anything yet. So let me just show you with another type of equation. Let's say I had a parabola, y equals x squared. Well, you don't see over here in the viewing window all of the parabola graphed. You only see the portion of the parabola graphed when x is less than 1, and that's because our timer right now is set at 1. If I increase my timer, you'll see more of the parabola being graphed. Now you see all of the parabola being graphed when x is less than 2. And likewise, if I go this way, I can see less and less of it graphed. So I want to put that timer into the computation layer. I don't want to have it done here. I want to have it be predicated on the student submitting something. So I'm going to get rid of this manual timer, and I'm also going to get rid of my my x squared and replace it with the f of x again. So we're back where we were before. We have two things that Desmos doesn't recognize, the function and the timer, T. And both of those we're going to put into the computation layer. Well, the function's already in there. And to define the timer, I'm going to use the number sync. It's capital T, and it's going to be based on input 1. And here are the sources for input 1. These are the different things we can have it be. We're going to make it be time sense submit. And basically what that's going to do is once the student here presses the submit button, it's going to activate the timer, and T is going to start counting from 0 on up, and it's going to go for 10 seconds. So let's see how this looks in preview mode, even though we have some more work to do, but I want you to see what's going to happen here. If the student types in y equals 3x, I'll put plus 1. You'll see part of this being graphed already. So that's not really ideal. The timer started at 0 and we graphed, and we have part of this graphed. So we have to start the timer back earlier so that it graphs gradually as we look at this graph being displayed. So here are the adjustments we want to make. What we want to do is back this up. So we want to back it up, and when I say back it up, I want to move it to the left. Watch what happens when I have x less than t minus 10. I'm going to go back into preview mode. If a student types in y equals 3x plus 1 again, and once they press submit, you have to wait for it. Here comes the timer graphing this dynamically, but it still stops here. Okay, it ran for 10 seconds, but it still stopped here, and I really wanted it to go further along so the student can get some interpretive feedback. So we need another small adjustment. To speed up the timer, the minus 10 moved it further left, so it was out of the student's view initially. To speed up the timer, we can add a coefficient in front. So the coefficient I like to use is 5 in there, but you can choose different coefficients there. Watch what happens when I put a 5 in front and we go back into preview mode. The student types in 3x plus 1 again. I keep putting in the same wrong equation. Once submit is pressed, that looks a little more dynamic, and that gives students a little more interpretive feedback so that they can maybe make an adjustment to put in the correct y-intercept, and this ideally is what we want. We want the students to match this graph. So once again here, the purpose of the 5 is to speed up the graph. The purpose of subtracting 10 is to move the timer back left a little bit so it's out of view of the student. And again, looking at the script in the computation layer, the function sync defines f based on what the student types in. So there are two different things happening with input 1. Input 1 provides what f will be, and input 1 also runs the timer. Another nice feature of using timers in Activity Builder is allowing students to see concepts develop, or seeing things develop maybe content-wise that you want them to see on a graph and see it gradually coming. So here's an example, and this is a little bit more advanced. It takes a little bit more work in the component to make it work. We're in preview mode here, and this is in Algebra 2, this would be a cubic graph right here. And if we want to, as teachers, show students visually what we mean by increasing or decreasing intervals, we can have that develop here using the concept of an action button this time. Notice the student doesn't have any blank to submit anything, so we're going to put in a timer here to connect to this action button. So let me just show you what this might look like. We might tell students to show the intervals. They'll click this action button, and then you'll see from left to right some dynamic graphing occurring. And what's happened here is it's showing the blue intervals we would call increasing intervals, and the red interval would be decreasing. And so let me just show you this again. There's the movement in there, and we've also identified a couple of changeover points, okay, which we would call, in Algebra 2, we call relative maximum, relative minimum points. And how do we get this to develop inside of Activity Builder? Well, let's exit the preview mode and take a look at what we have on this particular slide. Again, I've got a note component. I've got this time below it a button, an action button. An action button comes from over here. and I've labeled this button number 1. I've also got my graph component. Now I want you to take a look at what's in here. This might be a little intimidating at first. I've got basically 6 boxes worth of stuff here, okay? And 5 of them have little warning triangles here. Too many variables, blah, blah, blah. Well, let's talk about what these are. The first box I have is the polynomial I wanted graphed, and it's in factored form, and I've used green dashed. So that's what you're seeing right now, and that's what the students see initially. Then below that are the different aspects that I want that to show based on a timer. Now you'll see all of these say add slider T. That's because I've used T in all of these, much like I did on the previous screen, and you can't see some of them very clearly. Let me expand this out a little bit. There we go. All of these 5 have T in them. They all involve a timer, and they all involve something similar to what we just saw. Okay, except this time I have a different coefficient. I have a coefficient of 3 in there instead of 5 like I had in the previous one. So all of these have that particular notation in there. Now, if I were to add manually this slider, okay, here's the manual slider, those warning symbols go away. So this might be a little bit easier way to take a look at what these things are showing. What I have here are 2 points, and these 2 points are let me advance the slider a little bit here. There we go. I've moved the manual slider past both of these points. Here are the 2 points, the relative max, the relative min, but I put conditions on them. The conditions are that once my timer here is bigger than what the x coordinate is, this is going to show up. So let me bring the timer, let me bring T back lower again. You'll see up here there's no point showing, no point here. But once T gets past negative 0.786, let's see if I can get that to develop here. There we go. Once my timer gets past that point, it will show up. It will be graphed. And that's based on this domain restriction, if you will, and you'll see the label show. The second point does not show yet because my timer has not advanced far enough. But if I keep advancing it, then you'll see it show up. So boxes 2 and 3 here are those points with these restrictions in place. The second point's restriction has this same notation that I used earlier, but I want it to go past 2.12 because 2.12 is the x coordinate I want to show up. So once that gets past 2.12, this second point, this relative minimum, will show up. Now lastly, the last 3 boxes here are all portions, if you will, of what we started with up here. Now I've defined them as functions. Actually, this one I did not define as a function. It does, I guess it doesn't need to be if it's in factored form, but what I want to do is have specific conditions on them. For example, I'm going to click in this box, box number 4. This is identical to box number 1 in factored form. However, it's got an extra restriction in it. It's only going to graph when x is less than negative 0.786. So basically that's going to be the left-hand portion, the left-hand arm, if you want to call it that, of this polynomial. So this part will be graphed in blue as long as x is less than negative 0.786. The next box down, this one is also the same, and I guess I don't even need function notation, so let me take that out. It might clean this up a little bit. Next one down is basically the same factors, but this time it's got a domain restriction that x has to be bigger than 2.12. So this portion will graph in blue once x is bigger than 2.12. So we're essentially taking that initial function and we're breaking it into parts by domain restrictions. So both of these boxes have 2 domain restrictions. There's an x part, and then there's an x part based on the timer. So that's a little bit more complicated looking there. The last one I have here, notice is red. That's because I want this portion of the same graph to be done in red under this domain restriction. When X is between the negative 0.786 and the 2.12, and the timer has reached it, it's going to show up in red. So again, let me take this timer out, this manual timer. All of these now cannot graph because Desmos doesn't recognize what T is until we define it in the computation layer. And it's defined right here in the computation layer, similar to what I did on the previous screen. So it acts as a timer. Once the button is pressed, it'll start at counting with T at 0 and go up to 10. And I've also added here a sync to make my viewing window a certain viewing window. It's going to make the bounds go from, well, let me just highlight this part. The horizontal part is first, so it's going to make the X minimum -4. It's going to make the X maximum 6. And it's going to make the Y minimum and Y maximum -15 and 15 respectively. So let's take a look again in preview mode, how this might look. Once the action button is pressed, the timer starts, and we get this concept to reveal to students. Okay, thank you very much. Bye.